Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over question number 9 of our epic must-know trig identity proofs. We're going to be carrying out these proofs using the fundamental identities. This standard is covered in trigonometry and pre-calculus courses. Don't forget to take a look in the link at the description below, and there's a link there that will give you access to all these identities, and for each identity you will see a link that will take you to a video showing you exactly how the proof is carried out. Alright, so for question number 9, the task is to prove, we have to prove that the given identity is true. We have to prove that tan theta cotangent theta plus tan square theta is equal to secant square theta. Okay, all right, let's go ahead and do it. Now, before we get started, if you direct your attention to the yellow box to the right, you're going to see the strategy that we're going to be using. This is the strategy that we used for problems number 1 through 8. If you haven't taken a look at those examples, just take a look in the link in the description below, and then you will see all those problems, and you will see the link directing you to how they are done. Okay? All right. So if you take a look at this set of strategies right here, it guides us as to how we should do this problem. Now, if you take a look at the left side of the equation that we're trying to prove, you'll notice an operation plus a sum and the square of a trig function. We have plus tan squared theta. Now, whenever you have the sum or difference of a trig function square, the first thing that should come to your mind is what? The Pythagorean identities. You ask yourself, can I change the side that has the sum or difference of the trig function square into one of the Pythagorean identities? That will enable you to condense as indicated in step 3, and then you'll be able to complete your proof. Okay, so on the left side we have this plus tan squared theta. Now, in order for us to proceed, we want to ask ourselves, what identity, Pythagorean identity to be specific, has plus tan squared theta in it? And it is the identity 1 plus tan squared theta equals secant squared theta. Okay, this is one form of the Pythagorean identity involving tan squared theta. There are two other forms. You can also rewrite this as 1 equals secant squared theta minus tan squared theta. This is accomplished by subtracting tan squared theta from both sides. Or you can subtract 1 from both sides, and you have tan squared theta is equal to secant squared theta minus 1. Okay, so these are the three variations of the Pythagorean identity involving tan squared theta. Alrighty, so we can clearly see that number 1 is applicable to this particular problem because we have that plus and tan squared theta component that is present here. Okay, all right, so if we look at the identity, we're going to be using identity number 1. You notice that 1 is being added onto tan squared theta. So the question is, can we make use of the appropriate fundamental identities to reduce this product of trig functions into 1? That's the question. If you take a look at step 1 on our strategy for proving trig identities, we can see exactly how this can be accomplished. If you have the product or the quotient of trig functions and you desire to reduce them, the best strategy to use is to express both factors or your quotient as trig functions involving just sine and cosine only. When you do that, then you can easily divide out common factors that are present. That's the easiest way to do it. There are other ways to do it, but that's one way that I highly recommend. In this particular scenario, I'm going to show that to you. We're going to be using the quotient identities. I'll also tell you another way that this can be done. Okay, so using the quotient identities, tan theta can be rewritten as sine theta divided by cosine theta. And then using the quotient identities again, cotangent can be written as cosine theta divided by sine theta. Okay, plus tan squared theta equals secant squared theta. So you see, now it's apparent that there are common factors that can be divided out. Okay, so this is one way you can do it. Another way you could have done this is to implement the reciprocal identity to rewrite cotangent as 1 over tan theta, and then you can also divide in that way. So whichever way you like. Okay, all right, so what we just used here is the quotient identity. Okay, so now it enables us to identify common factors, which we will divide out. Cosine theta goes here 1, cosine theta goes here 1, sine theta goes here 1, and sine theta goes here 1. Now when you multiply these numbers on the left side of the sum, you have 1 plus tan square theta is equal to secant square theta. Now when you take a look at the Pythagorean identity we have on the left here, number 1, we can clearly see that 1 plus tan square theta can be rewritten or condensed to secant square theta using the Pythagorean identity. Okay, so we're going to condense the left side of this equation. 1 plus tan square theta can be condensed into secant square theta using the Pythagorean identity. And on the right side, we have secant square theta. Both sides are the same. Ladies and gentlemen, we're done. Remember, you're done with a proof of identities if you can show that the left-hand side is equal to the right-hand side by applying the appropriate trig identities. Okay, so let's go ahead and specify what we did. So from the second to the third step, all we did was to just simplify, dividing out common factors, and then lastly, we made use of the what? We used the Pythagorean identity to condense that sum of squares, Pythagorean identity, and we had our final answer. Alrighty, so that's how you show that tan theta cotangent theta plus tan squared theta is equal to secant square theta. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of trig identities and how to prove them, do give us a like or a thumbs up. Your positive feedback is extremely important to us. Don't forget to subscribe to our channel. We upload videos to our YouTube page on a regular basis. So if you subscribe, you get notification of our uploads. If you have any questions or comments about the video we just went over, or if you have any special requests for a trig identity that you would like us to prove, just post it in the comment section below and we will be more than glad to assist you. As indicated earlier, if you take a look at the link in the description, you have the link to the worksheet that has all the trig identities. And also you can visit our website at mathgotserved.com for a wide variety of tools to help you in your studies of mathematics. Thanks again for watching and have a wonderful day. Goodbye.